Civil engineering has always been at the heart of infrastructure development, but the integration of information technology is now revolutionizing the field. In the Kurdistan region of Iraq, rapid urban expansion has created an urgent need for more efficient planning, construction, and maintenance of public infrastructure. The Ministry of Municipalities, responsible for overseeing 175 municipalities, has faced challenges with traditional manual workflow. This presentation is based on an MSc Master Degree in Management Information Systems (MIS) thesis discussion conducted by researcher Dr. Qasim Hamakhurshid Hamamurad in 2012, Erbil. The thesis, titled ITCE Information Technology for Civil Engineering, explores how advanced IT tools are reshaping civil engineering practices. You will see how technologies such as GPS, Total Station, GIS, and AutoCAD Civil 3D bridge operational gaps, enhance accuracy, and streamline collaboration. This case study demonstrates how digital transformation can significantly improve efficiency and decision-making, setting the stage for a new era in municipal and infrastructure development. Kurdistan region in northern Iraq has seen rapid urban growth, creating urgent demands for efficient infrastructure planning and maintenance. The Ministry of Municipalities oversees 175 municipalities, managing everything from roads and water systems to waste disposal and urban development. Historically, these departments operated in silos, relying on manual drawings and limited integration. This often led to delays, redundant work, and inconsistencies between design and reality. The need for modernization was clear, and the ITCE initiative emerged as a solution to unify workflows and improve project outcomes. For integration, civil engineering designs in Kurdistan relied heavily on two-dimensional drawings and manual measurements. Without precise geographic referencing, these designs often failed to match the actual ground surface, resulting in inefficiencies and costly discrepancies. Departments like GIS, survey, and design worked independently with little information sharing. This fragmented approach created information silos and slowed down project execution. Recognizing these challenges, the ministry sought a unified solution to bridge gaps and streamline processes. Information Technology for Civil Engineering (ITCE) method was introduced to address these issues. ITCE integrates spatial data from satellite imagery and GIS databases with attribute data collected from GPS and total station surveys. Using AutoCAD Civil 3D, engineers can process this data to create accurate surfaces, contour lines, and design models. The key innovation is real-time data sharing across departments, enabling collaborative design and implementation. This approach not only improves accuracy but also boosts efficiency and cost-effectiveness. Modern civil engineering projects in Kurdistan now utilize a combination of ground-based and satellite-based surveying technologies. Garmin GPS receivers collect georeference points, while Leica total station instruments provide high-precision measurements. LiDAR scanning is used in select projects to capture dense point clouds for terrain modeling. All this data is processed in AutoCAD Civil 3D, allowing for detailed surface modeling and design. The integration of these tools ensures that every project is based on accurate, real-world data. Management Information System (MIS) framework underpins the ITCE approach, providing structured storage, processing, and distribution of information across departments. MIS enables real-time data exchange between survey teams, designers, GIS analysts, and field crews. By integrating spatial and non-spatial data, MIS improves decision-making and reduces redundancy. This structured approach is essential for coordinating complex infrastructure projects and ensuring that every team has access to the latest information. GIS platforms are used to store, manage, and visualize spatial data, while AutoCAD Civil 3D specializes in creating detailed engineering designs. By integrating GIS with Civil 3D, engineers can overlay satellite imagery, contour data, and field-collected coordinates to produce accurate and contextually relevant designs. This combination is particularly valuable in regions like Kurdistan, where geospatial databases are still developing. The synergy between GIS and Civil 3D enables more precise and efficient project planning. Adopting advanced IT and civil engineering is challenging in developing regions due to limited budgets, lack of skilled personnel, and resistance to change. However, targeted training, phased technology integration, and government support can accelerate adoption and deliver significant benefits. Case studies from Malaysia, India, and Turkey show that these strategies improve project quality and efficiency. Kurdistan's experience demonstrates that with the right approach, it can transform infrastructure development even in resource-constrained environments. Kurdistan Ministry of Municipalities case study combines qualitative and quantitative methods, including field surveys, workflow analysis, and interviews with engineers and officials. The focus is on documenting the tools, processes, and outcomes of the ITCE approach in real-world projects. This research design ensures a comprehensive understanding of how IT integration impacts municipal infrastructure, providing valuable insights for future implementation. ITCE method employs a range of surveying instruments. GPS devices collect georeference points, total stations measure angles and distances, and LiDAR scanners capture high-density terrain data. AutoCAD Civil 3D processes this information to generate surfaces, contours, and design drawings. GIS software manages spatial datasets and master plans. Together, these tools provide a comprehensive foundation for accurate and efficient infrastructure design. Ministry operates through multiple directorates, each with specialized functions such as urban road construction, highway maintenance, water distribution, and urban planning. Historically, these departments worked in isolation with limited information sharing and no real-time coordination. The ITCE approach breaks down these barriers, enabling departments to collaborate on shared datasets and streamline project workflows. This shift is crucial for delivering complex infrastructure projects efficiently. Prior to ITCE, several challenges hindered progress. Departments lacked integrated communication, designs were based on manual dimensions without real topography, data sharing mechanisms were limited, and survey data was inefficiently used. These issues led to delays, mismatches between design and reality, and redundant work. Addressing these challenges required a fundamental shift in how information was collected, processed, and shared. ITCE solution integrates spatial data from satellite imagery, attribute data from field surveys, and design processing in AutoCAD Civil 3D. By linking these technologies through a land-based MIS framework, departments can collaborate in real time, sharing updated datasets and master plans. This unified workflow eliminates duplication, reduces delays, and ensures that every project is based on accurate, up-to-date information. Field surveys use GPS for preliminary location marking and total station instruments for detailed measurements. Data is transferred to computers, processed through MapSource and Leica FlexOffice, and imported into AutoCAD Civil 3D. Surfaces are generated using the TIN method, and contour lines are created at specified intervals. Satellite imagery from Google Earth adds visual context, ensuring designs are both accurate and relevant. Processed datasets are stored on the ministry's local area network, enabling real-time sharing between GIS, design, survey, and IT departments. The GIS department updates master plans and returns updated spatial datasets to design teams. Survey crews receive completed design coordinates for construction staking via wireless transfer. This seamless data flow is key to efficient project implementation. ITCE method was applied to 10 municipal projects across Kurdistan, including road design, sanitary and waterworks, office building surveys, and utility network upgrades. These projects provided diverse conditions for testing ITCE's capabilities in urban, semi-urban, and rural terrains. The standardized workflow proved adaptable to various project types, demonstrating its scalability and effectiveness. Integrating GPS, total station, and Civil 3D significantly reduced discrepancies between design models and actual topography. Field validation showed that ITCE-generated surfaces had an accuracy within plus or minus 2 cm, compared to deviations exceeding plus or minus 15 cm in pre-ITCE designs. This leap in precision minimizes costly construction errors and ensures that infrastructure projects meet real-world conditions. Land-based MIS framework enabled simultaneous access to updated project data across departments, reducing project delays by about 30% and eliminating duplicate survey efforts. Real-time collaboration ensures that every team works with the latest information, speeding up project delivery and improving overall efficiency. This level of coordination is a game-changer for municipal infrastructure management. By reducing rework and improving planning accuracy, ITCE contributed to measurable cost savings across the studied projects. Surveying and design-related costs decreased by 15–20%, primarily through reduced working hours and minimized material waste during construction. These savings demonstrate the tangible benefits of IT integration in civil engineering. Standardized ITCE workflow can be replicated across other ministries or municipal agencies in Kurdistan. It is adaptable to various project types, including roads, water networks, sewerage systems, and public buildings. This scalability ensures that the benefits of IT integration can be extended to a wide range of infrastructure projects, supporting sustainable urban development. Kurdistan Ministry of Municipalities experience with ITCE shows that integrating GPS, total station, GIS, and AutoCAD Civil 3D into municipal workflows dramatically improves project outcomes. Design accuracy, data processing speed, coordination, and cost savings all saw significant gains. For future success, the ministry recommends continuous training, IT infrastructure upgrades, standardized workflows, policy integration, and expanding ITCE to include drone-based photogrammetry and BIM. This case study provides a blueprint for other developing regions seeking to modernize their civil engineering practices.